related rates or rate problems, you can solve rate problems in many ways. You can write equation from equivalent ratios. Equivalent ratios have the same units in their numerators and the same units in their denominators. You can multiply especially to convert from one unit to another, include the units with each term in the product, then eliminate the units. Try representing constant rate of change with a linear function. Okay. So long and short of it is, and then this is how I did this yesterday, and this is how I teach it in physics, is you want to stack with ratios that you know in order to get to units that you need. All right? So for example, Michael must order snacks for an office meeting of 170 people. He decides to order tarts, which come in boxes of 12. He estimates that he'll need 1.5 tarts per person. How many boxes should Michael buy? Okay. So the first thing that we want to do is find out the number of boxes, right? Okay, so we've got 170 people and they're going to need 1.5 tarts per person, correct? So let's just find out how many tarts total that would be. So I've got 170 tarts by, or sorry, there's 170 people, right? 170 people by 1.5 tarts. So how many is that? 255. 255 is the approximate number of tarts, right? Okay, so I have 255 tarts. Now, what's my conversion if I want to find out the number of boxes? So I've got boxes to tarts. One box has 12 tarts. Has 12 tarts in it. So I do the ratio the same as I do any other ratio. Okay? So do I divide by 12 or multiply by 12? Divide because it's on the bottom, correct? So 255 divided by 12 gives me 21.25. 21.25 boxes. So how many boxes am I actually going to need there? 22. 22, right? Because otherwise I'll be short. Okay, so that's pretty simple. The one thing that you want to do is we want to get used to that correct rounding. Okay? Because theoretically, if we round the way we've been taught to round, you would round down, right, to 21. But when you talk about certain things, you may need more in order to cover it. When we do mortgages next year in applied math, you're going to find out that you'll get like 21.25 years in order to pay off a loan. So what do? You take more time in order to pay it off. In terms of people, if we had 21.25 people as part of our answer, we would only have 21 people because you couldn't have a quarter of a person. So those are things that we want to get used to this year. All right, let's look at the second example. Jenna wants to defrost a turkey in her microwave. The turkey has a mass of 4.23 kilograms. A cookbook says it takes 21 minutes to defrost 3 pounds of meat. How long to the nearest minute? Okay, so our goal is to find out the number of minutes. And it gives us the turkey, first of all, in kilograms, but it gives us the conversion in minutes for pounds, right? So we have 4.23 kilograms. So the first thing we want to do is let's change that to pounds. So what's the ratio? 2.2. 2.2 over 1. Okay? So now, I cancel out my units. When I have units on the top and units on the bottom, I cancel those out. Okay? So now I've got the turkey size in pounds, right? And then, what's my ratio of minutes?
21 to 3.
21 to 3. 21 minutes for 3 pounds. Okay? So, I cancel out the LBS, right? And what am I left with? What's my final units? Minutes. So, multiply across the top, divide by the bottom, and what do we get?
65.142.
65.142 minutes to defrost turkey. Okay? Questions so far? right, third example. Now we're comparing two ratios here. Bob burns 620 calories in a cardio kickboxing class lasting 2 hours. He also burns 120 calories in a body sculpting class lasting 30 minutes. If he does cardio kickboxing for 3 hours, how much longer would he have to do the body sculpt to burn the same number of calories? All right. So, first thing we want to know is how many calories is he going to burn through the cardio kickboxing? So how long does he do it for?
2 hours.
Does it for 3 hours cardio kickboxing, correct? Is that right? And then he burns how many calories? 620 calories over how many hours? 2 hours. Which is equal to how many calories did he burn total?
930.
So he burned 930 calories. Now I need to find out the amount of time he'd have to do the body sculpting for in order to do that. Correct? So I have 930 calories and I want to find time now. So what's the body sculpting ratio then?
120 calories in 30 minutes.
Okay, so 0.5 hours. Okay, or actually we can change that to minutes. So I have 30 minutes. And how many calories? Sorry, I missed that.
120.
120 calories. So how long is it going to take him to burn that 930 calories just using the body sculpting?
232.5 minutes.
232.5 minutes. And if I wanted to convert that to hours, what do I do? 5 by 60, and what is it for hours?
3.875.
Depending on what the question asked. Okay? Did anybody have issues with yesterday's assignment? No? You won't have issues with this today then. Okay? Because it's almost exactly the same. They're adding a couple steps in, just one more conversion or two more conversions onto it to do it. Okay? So it's all right. Were there any questions from yesterday's assignment that you couldn't get? Nobody asked anything. Seemed like we did okay. All right. Okay. So again, this is fairly straightforward. Look at page 228 then. We're going to look at scale diagrams. All right. So this part is where we start to get a little bit on the confusing side of things, but I think we'll be okay if we just kind of pick through it fairly slowly. So let's take a look at the keep in mind box there. It says you can represent a 2D shape using a scale diagram. What scale you use will depend on the size both of the actual shape and the diagram you need. A scale factor K compares the measurement of a shape in a diagram to the measurement of the actual shape as a ratio, with both measurements in the same units. So K is equal to the diagram measurement over the actual measurement. So first thing you want to do is make a massive note of this right here. Okay, because we're going to go into areas next and then volumes after that. All based on this K factor. So the first thing you need to know is in the same units, you have the diagram measurement, the ratio is always diagram measurement to actual measurement. So your diagram to your actual measurement. So an example, if a desk is 150 centimeters long and is drawn in a diagram as 15 centimeters long, then the K factor is 15 centimeters, because that's your diagram, to 150 centimeters, which is a K factor of 0.1. All right? So where do you see these being used most often? These scale diagrams. Where would you see this being used?
Map.
Maps. Absolutely. Map on the back wall there. Okay, scale diagram of the world. Where else would you use it?
Architecture.
Architecture. Okay, if I wanted to find out the size of this floor and I wanted to draw it on paper, obviously it would be a big piece of paper if I drew the floor to the actual size. So I'm going to measure the floor size out and then I'm going to put it on paper, but I need a scale so that I know what it is. So anything, house, buildings, whatever, scale diagrams are used. Okay, and so it's diagram measurement to actual measurement, but the key is you need to have the same units. All right, that's the important part. Okay, you can also multiply any linear dimension of shape by a scale factor to calculate the dimension of a similar shape. So if the ratio is between 0 and 1, make a note of this. If it's between 0 and 1, you're taking a larger object and making it smaller on the page. So to think of that, you're taking a building and putting it on paper. Okay? All right? So larger to smaller. If the scale factor is greater than 1, that means you're taking a small object and making it much larger. So you're taking the size of an ant and drawing it on a piece of paper. Okay, and not to scale size, but bigger, larger size. All right? So that's important. You're going to want that on your cheat sheet. Okay? Look at the example here. Create a scale diagram of this building footprint using a scale of 1 meter is equivalent to 1,000 meters. Okay? So, is the ratio between 0 and 1 or greater than 1? 1 to 1,000?
0 and 1.
Between 0 and 1, right? That's 1/1000th. Okay, so 0.001, right? So that means that we're taking that diagram and we have to do what with it? Make it larger or smaller? Smaller. Okay, but the problem is we have meters. So we need a big piece of paper for it because our ratio is still in meters, 1 meter to 1,000 meters. So what should we do with this then? Well, let's take a look at this. We have the first measurement I see is 5 meters across the top. And I'm going to use the ratio that I have been given, which is 1/1000, right? So what do I do with that 5? Divide it by 1,000 and I end up with 0.05, correct? So what is 0.05 meters in centimeters? It's 5 centimeters. So now I draw it to 5 centimeters. Okay? So now on your piece of paper you're going to draw it to, actually it's not 0.05, that'd be 100. 0.005, which is really small because then that's half a centimeter. Okay? So you're going to need a ruler for this. All right? And you're going to have to draw this out. Okay, so they show you the example exactly what's going on in the steps. So I determine the scale factor and consider whether the diagram would be a reduction or an enlargement. The scale factor K is 1/1000. Since the value is less than 1, the diagram will be a reduction. I then multiplied each measurement by the scale factor. So I've got 20 times 1 over 1,000, 15 times 1 over 1,000, 5 times 1 over 1,000, and 10 times 1 over 1,000. And then I drew the scale diagram on a piece of paper. Okay, so you're going to have to draw out today, using a ruler, the scale diagrams. Let's take a look at example 2. A cross-section of an animal cell is shown in a scale diagram. In the diagram, the diameter of the cell is 4.5 centimeters. In fact, the cell's diameter is 0.15 millimeters. What scale factor was used? Okay, so I need to find the scale factor, K. So what was the diagram measure? 4.5 centimeters. What was the actual measurement of the diameter? 0.15 millimeters. So what do I do? What do I need to do in order to find the K value?
Make them the same.
Make them the same. So what do we want to change? Centimeters to millimeters or millimeters to centimeters? Centimeters to millimeters. How many millimeters is 4.5? How do you get that? Times by 10. There are 10 millimeters in 1 centimeter, right? So I've got 45 millimeters to 0.15 millimeters. So what's the K factor? So what's the magnification of the microscope? Magnification, 300 times the actual value, okay? So did the microscope enlarge the object or reduce it? Enlarged it, okay? So like I said, we want to really focus on this today. Make sure that you know how to find that K factor, because the next 2 units are area and volume using your K values. All right? So it's necessary that we get this under control today. Okay? And that's it. So you have today to finish 8.2 and 8.3 up.